Dear students, good morning to all. Welcome to the today's session. I hope all of you and your families are staying safe and well during this challenging time. Okay, we already started motion in a straight line. We discussed a lot about this chapter in previous videos. Motion of a particle in a straight line. Motion in a straight line chapter. But we already studied a lot. In our previous video, we discussed about what? Speed and velocity. So what is speed? The rate of distance traveled by a body is called speed. We studied what? Uniform speed, uniform motion, average speed, and also instantaneous speed. Similarly, we studied what in previous class? Velocity. So what is velocity? What is velocity? We studied velocity. So what is velocity of a body? Velocity of a moving body can be defined as the rate of displacement of the body with respect to time. The rate of displacement of the body with respect to time. The rate of displacement of the body. The rate of displacement of the body with respect to time is known as what? Velocity. That is, velocity of a moving body is given by displacement divided by time taken. Displacement by time. Displacement divided by what? Time. So once again, what is the SI unit of velocity? So unit of velocity is, see, displacement. We studied in our previous video. The change in position of a particle in a particular direction is known as what? Displacement. The change in position means magnitude of the length of the path. Exactly. Magnitude of the water displacement is measured in terms of physical quantity known as length. So length is measured in terms of unit known as meter in SI system. So unit is what? Meter per second. Mana meter per second in SI systems. So what is the dimension of velocity? Ayana. So dimension of velocity is given meter. Say L. Time T to the power of minus 1. So LT inverse 1 or M to the power of 0 because no role of mass in velocity. Therefore LT inverse 1. We know velocity is nothing but displacement by time taken. In previous class, in previous video we studied that displacement is a vector physical quantity. Hence, velocity is also vector physical quantity. Means it has both magnitude and directions. It has both magnitude and directions. Therefore, because displacement is the vectors, even if time is scalar, but displacement is not vector, hence velocity is a vector. So it has both magnitude and direction. ಮೌಲ್ಯ ಮತ್ತು ದಿಕ್ಕು ಕೂಡ ಇದೆ. Therefore velocity may be negative or zero or positive. We discuss about it later. Okay, see, velocity of a body is given by displacement by time taken. Velocity of body displacement by time. If t is equal to, if time is 1 unit, if time is 1 unit, then velocity is nothing but what? Displacement per unit time. Got it? See, when time is equal to 1 unit, then velocity equal to displacement. Therefore, velocity of a moving body can be defined as displacement per unit time. Displacement per unit time. Displacement per unit time. We already studied about it in our previous video. Again, we know if a body covers equal displacements in equal intervals of time. If a body undergoes equal displacements in equal intervals of time, if a body undergoes equal displacements in equal intervals of time, then velocity of the body is said to be what? Uniform velocity. So what is meant by uniform velocity of a body? body is said to be moving with uniform velocity if it undergoes equal displacements in equal intervals of time. However, the small time intervals will be. Isn't it? The velocity of the body is said to be uniform. The velocity of the body is said to be uniform. The velocity of the body is said to be uniform. Said to be uniform. Velocity of the body is said to be uniform. If it undergoes equal displacements. If it undergoes equal displacements. If it undergoes equal displacements in equal intervals of time. In equal intervals of time. In equal intervals of time. Isn't it? Distance by what? In equal intervals of time. However, the small time intervals may be. However, the small time intervals may be. However, the small time intervals may be. Intervals may be. So we already stated about this uniform velocity in previous video, but taking one good examples. See, if a body covers equal displacements in equal intervals of time, then velocity of the body is said to be uniform. Remember, students, I told you velocity is a vector physical quantity. It has both magnitude and direction. Velocity has both magnitude and direction. ಅದಕ್ಕೆ ಮೌಲ್ಯ ಹಾಗೂ ದಿಕ್ಕು ಎರಡೂ ಇದೆ. Means velocity not only indicates how quickly body moves. It gives an idea about along with how quickly body moves in what direction it will move. That's the concept of the velocity. Therefore, see, velocity of the body is said to be uniform means both magnitude and direction remains constant. Both magnitude and directions of the velocity means what? Constant. If magnitude of the velocity changes, even if direction is same, velocity is said to be non-uniform. If only direction changes, then also velocity is said to be non-uniform. If both magnitude and directions of the velocity changes, then also velocity is said to be what? Non-uniform. Got it? That is, when the velocity of the body is variable. What is a variable velocity? A body covers unequal displacements in equal intervals of time, or equal displacement in unequal intervals of time, or body covers unequal displacements in unequal intervals of time. That is, velocity of the body is said to be variable if its magnitude changes, or if its direction changes, or if both magnitude and direction changes. When the velocity of the body is non-uniform, then the motion of the body is described in terms of average velocity. See, when the velocity of the body is non-uniform, the motion of the body is described in terms of its average velocity. So my next topic is what? Average velocity. Average velocity. So we are already studying average speed and explain average run rate of an one-day match. Isn't it? In previous video, I explained average run rate of an one-day match. How can you find the average run rate of an one-day match? Total number of runs divided by total number of overs pushed to make these runs. I told you, some overs may be expensive, or some overs may be economical. Isn't it? Some overs may be what expensive, or some may be what economical. But average means that is what? Total runs by total time takers. Total runs by total time takers. Similarly, what is average velocity? Total displacement of the body divided by total time taken. In our book given total displacement of the body by total time. What that is, it can be defined as the ratio of the ratio is divided. It can be defined as the ratio of the total displacement of the body. The ratio of the total displacement of the body. Total displacement of the body. Total displacement of the body to the total time taken. To the total time taken. To the total time taken. Total time taken is nothing but what? Average velocity. That is, average velocity of a moving body can be defined as the total displacement of the body divided by total time taken. That is average velocity. That is average velocity is given by total displacement. Total displacement divided by total time taken. Total displacement by total time taken. Let us consider that x1 and x2 are the, say, let x1 and x2, let x1 and x2 are the position of the body. We know as long as body is in motion, ಒಂದು ವಸ್ತು ಎಲ್ಲಿಯ ತನಕ ಚಲಿಸುತ್ತಿರುತ್ತದೆ ಅಲ್ಲಿಯ ತನಕ ಅದು ತನ್ನ ಸ್ಥಾನವನ್ನು ನಿರಂತರವಾಗಿ ಬದಲಾಯಿಸುತ್ತಿರುತ್ತದೆ. Isn't it? Let x1 and x2 are the position of the body. Say positions of a body. Positions of a body at any instance. At any instance, T1 and T2 respectively. At any instance. At any instance, T1 and T2 respectively. T1 and T2 respectively. What you understood from this discussion, students? See, when time T1, body is at position x1. After the time T2, body is at position x2. Now, what is the displacement of the body? x2 minus x1. What is the displacement? Changing positions in a particular directions. What is the time taken by the body to change position from x1 to x2? T2 minus T1. Displacement of the body is given by, see again, displacement of the body. See that x1 and x2 are the position of your body at any instance T1 and T2 respectively, means that displacement of the body. So what is displacement of the body? See, displacement of the body is given. Displacement is equal to what? x2 minus x1. Time interval, time taken. See, time taken. What is time taken by the body to change from x1 to x2? T2 minus T1. So time taken by the body to change from position x1 to x2 is T2 minus T1. Now average velocity of the body is given by. Now, what is the average velocity? We understood total displacement by total time taken. Total displacement by total time taken. Remember in our NCERT book, this average velocity represented by putting bar over the v. It has v bar. V bar. So v bar is given displacement x2 minus x1. Time taken t2 minus t1. Therefore, x2 minus x1 divided by t2 minus t1. Or average velocity of the body is given by v bar is equal to what? Delta x divided by delta t. It is what? Average velocity of a moving body. Average velocity of what? Moving body. I hope that all of you understood the studies. Any doubt? So what is average velocity? Average velocity of a moving body can be defined as the ratio of the total displacement of the body to the total time taken, or displacement of the body by divided by total time taken. Let x1 and x2 are the position of a body at any instance t1 and t2 respectively. Displacement of the body is x2 minus x1. Time taken is t2 minus t1. Now average velocity of the body is given by v bar is equal to x2 minus x1 by t2 minus t1. So v bar is equal to what? Delta x by delta t. Delta x by what? Delta t. This is what? Average velocity. Remember, average velocity itself is nothing but velocity of the body. Because average velocity is very important whenever body is moving with variable velocity. Okay, now if the velocity of the body continuously changes, then in order to study the motion at a particular instant, we take the what? Instantaneous velocity. My next topic is instantaneous velocity. Instantaneous velocity of a moving body. We already studied about instantaneous speed. What is instantaneous speed? Speed of a moving body at a particular instant of time is known as instantaneous speed. So, now my next topic is called instantaneous velocity. Instantaneous velocity. Instantaneous velocity. So, what is instantaneous velocity? I am explaining it. We are discussing instantaneous speed. When an athlete starts running, gradually he or she increases the speed and finishes his or her race with high speed. That is a different instant of time, speed are different. Similarly, if a different instant of time, velocity are different, means if a body moves with variable velocity, then we can define what instantaneous velocity. So what is instantaneous velocity? It can be defined as velocity of a body at a particular instant of time. It can be defined as velocity of a body, velocity of a moving body, velocity of a moving body, velocity of a moving body at a particular instant of time. At a particular instant of time. At a particular instant. ನಿರ್ದಿಷ್ಟ ಕ್ಷಣದಲ್ಲಿ ಒಂದು ವಸ್ತುವಿನ ವೇಗವೇ instantaneous velocity. That is, it can be defined as velocity of a moving body at a particular instant of time. Is known as what? Instantaneous velocity. Any doubt? But assume we have that x be the displacement of the body. Say that x be the displacement of the body. Means that x be the what? Change in position of the body. That x be the displacement of the body. Say that x be the what? Displacement of the body. Displacement of the body in the time t. In time, say t. Right? Let x be the displacement of the body in time t. After the time t plus delta t. And x plus delta x and x plus delta x be the displacement of the body. X plus delta x be the displacement of the body in time t plus delta t. I told you. What is delta? Delta equals to very small. Delta equals to very small. That is, after a small change in time, after a small increase in time, displacement becomes x plus delta x. So I told you delta equals to what? Small change. We know now delta x becomes. Now delta x be the. Now delta x is the displacement displacement of the body in time delta t. Isn't it? See, let x be the displacement of the body in time t. And express delta x be the displacement of the body in time t plus delta t. Now delta x is the displacement of the body. Delta x is what? Displacement of the body. Displacement of the body in time delta t. What is in time? Say delta t. In time delta t. So we know as delta t tends to 0, because I told you delta refers to very small, isn't it? Delta refers to what? Very small. As delta t tends to 0, means as a change in time, as time interval approaches to 0, as delta t tends to 0, then delta x also approaches to 0. Isn't it? That is, delta t tends to 0, then delta x also approaches to 0. Got it? That is, in small time, in small interval, the displacement of the body is also very small. Now, average velocity of the body is given by. Now, average velocity of the body is given by. Now, average velocity is what is average velocity? Displacement. Now, average velocity of the body. Now, average velocity of the body. So, what is average velocity? Say v bar is equal to delta x divided by delta t. Delta x by delta t. Average velocity of the body is delta x by delta t. Rate of change of displacement, total displacement by total time taken. I told you that as delta t approaches to 0, delta x also approaches to 0. But the ratio delta x by delta t has a finite limit. I am explaining clearly this by discussing instantaneous speed story. Instantaneous speed ಹೇಳುವಾಗ ಒಂದು example ಕೊಟ್ಟಿದ್ದೆ, isn't it? For example, in time delta t, if delta x is equal to 0.1 meter, in time delta t is equal to 0.01 second. 0.01 second. Then what about velocity? Delta x by delta t. See, what is delta x by delta t? V1 is equal to what? 0.1 divided by 0.01. What is 0.1 by 0.01? 10 meter per second. See, as delta t approaches to 0, then delta x approaches to 0, but delta x by delta t has a finite limit. Because there is the finite. Therefore, instantaneous velocity of a body is given by. Therefore, instantaneous velocity of a body is given by. So, what is instantaneous velocity? Mathematically, we can write like this. See, instantaneous velocity of a body is given by, because delta x by delta t has the finite limit. Therefore, instantaneous velocity, say v is equal to instantaneous velocity, say v is given by, v is equal to what? Limit of delta t tends to 0. Limit of delta t tends to 0, delta x divided by delta t. Delta x by delta t is the what? Mathematical formula used to represent what, student? Instantaneous velocity. Got it? As instantaneous velocity of the body is given by v is equal to limit of delta t tends to 0, delta x by delta t. Remember, speed or velocity shown in the speedometer of the vehicle is the instantaneous speed or instantaneous velocity. You bike will ಹೋಗ್ತಾ ಇದ್ದೀರಾ, as you raise the acceleration to your bike, then needle in the speedometer shows the deflections of larger amplitude. ಹೇಳುತ್ತೆ ಜಾಸ್ತಿ ಆಗ್ತದೆ speedometer of the vehicle indicates what? Instantaneous. A different instant of the speed of the reading shown by the speedometer is what is defined. Therefore, the reading of the speedometer observed in vehicle is instantaneous speed. We can say instantaneous speed or instantaneous velocity. It is of what student? Instantaneous velocity. Any doubt? See, so first type what? Velocity. Uniform velocity. Average velocity. Instantaneous velocity. I hope that all of you understood clearly. Now I am going to discuss about difference between speed and velocity. Very important questions. Very important questions. Difference between speed and velocity. Now I am going to discuss about what? Difference between speed and velocity. Because so far we studied, starting from the last video, last sessions, we discussed what is speed and velocity. Okay. Now I am going to discuss the difference between speed and velocity. So in one of our sessions we have already studied what are the difference between distance and displacement. Distance and displacement. Now I am going to discuss about the difference between what the speed and velocity. Speed. Okay, one column is the speed. I will write here next velocity. I will write velocity at this side. Velocity is the speed. Okay. First difference. Write the definition, students. The distance travelled per unit time is classified. Simple definition. The distance travelled. The distance travelled. Isn't it? The distance travelled per unit time. The distance travelled per unit time. The distance travelled per unit time is known as what? Speed. Distance travelled per unit times. Distance travelled per unit time. I will write time here. Distance travelled per unit time is called speed. Is called speed. Distance travelled per unit time is called speed. What about velocity? The displacement per unit time. The displacement of a body per unit time. The displacement per unit time. The displacement per unit time. The displacement per unit time is called velocity. Is called velocity. The displacement per unit time is called velocity. Got it? Second point. Second point. It is a scalar. It has no direction. Only magnitude. Even if the body come back to the initial position, speed of the body not equal to 0, because speed is always taken as positive. Speed never be negative. Because it is a scalar. It is a scalar. It is a scalar quantity. It is a scalar physical quantity, or simply we can say scalar quantity. It is what scalar adisha. ಇದಕ್ಕೆ ದಿಕ್ಕಿಲ್ಲ, ಮೌಲ್ಯ ಮಾತ್ರ. As long as the body is in motion, as the distance traveled by the body increases, isn't it? Momentum speed increases, speed may be constant. Got it? Therefore, it is a scalar quantity. But what about this one? It is a vector quantity. It is a vector physical quantity. It has both magnitude and direction. ಇದಕ್ಕೆ ಮೌಲ್ಯ ಮತ್ತು ದಿಕ್ಕು ಎರಡೂ ಉಂಟು. ಇದಕ್ಕೆ ಮೌಲ್ಯ, how quickly body moves, in what direction it moves, ಎಷ್ಟು ವೇಗದಲ್ಲಿ ಹಾಗೂ ಯಾವ ದಿಕ್ಕಿನಲ್ಲಿ, ಎಷ್ಟು ವೇಗದಲ್ಲಿ ಹಾಗೂ ಯಾವ ದಿಕ್ಕಿನಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. This is the measure of velocity. Got it? Third point. Third one, since it is a scalar means always positive. Speed is always positive. Speed of a particle. Speed of a particle is always positive. Remember, it is always positive. What about velocity? What about velocity? Velocity of a particle. Say, velocity of a particle may be negative. May be negative. Velocity of a particle may be negative or zero and very positive. See, velocity of a particle may be negative, zero and positive. And positive. And what? Positive. This is the difference. But speed of a particle is always positive. Velocity of a particle may be negative, zero and positive. What about the fourth difference? If the speed is constant, velocity may not be constant. Speed ಸ್ಥಿರವಾಗಿದ್ದರೂ ಕೂಡ velocity ಸ್ಥಿರ ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಆಗಲ್ಲ. Why? Speed constant means only magnitude remains constant, but velocity is said to be constant, both magnitude and direction constant. Because speed does not give any idea about directions of the motion of the body. Got it? Speed ಎನ್ನುವಂಥದ್ದು ಒಂದು ವಸ್ತುವಿನ ಜವ ಇದ್ದರೆ, ಒಂದು ವಸ್ತುವಿನ ಜವ ಎನ್ನುವಂಥದ್ದು ಆ ವಸ್ತು ಯಾವ ದಿಕ್ಕಿನಲ್ಲಿ ಚಲಿಸುತ್ತಿದೆ ಎನ್ನುವ ಐಡಿಯಾಸ್ ನಮಗೆ ಕೊಡುತ್ತವೆ. It gives only what how quickly body moves or how slowly body moves. Got it? Therefore, if speed is constant, speed is constant, velocity may not be constant. If speed is constant, velocity may not be constant. Velocity may not be constant. Speed ಸ್ಥಿರವಾಗಿದ್ದರೆ velocity ಸ್ಥಿರ ಆಗಿರಬೇಕಂತೇನಿಲ್ಲ. Explain it later by using an example. Okay? If speed is constant, velocity may not be constant. Velocity may not be constant. Speed ಸ್ಥಿರವಾಗಿದ್ದರೂ ಕೂಡ velocity ಸ್ಥಿರ ಆಗಿರಬೇಕಂತಿಲ್ಲ. Why? Speed constant means only magnitude of the speed means because speed has only magnitude. See, for example, say a body moving along a circumference of a circular path. Say a body moving along a circumference of a circular path. See, assume body moving along a circumference of a circular path of radius say about some amount of radius, say 10 centimeter or 10 meter. So whatever speed of the particle is given by 20 meter per second. At any position during its path, speed remains constant because only magnitude is 20 meter per second. But let us choose a point A, B, C, D are different positions of the particle along the circular path. We know what is the directions of the motion of the particle along the curved path. Directions of the motion of a particle along a circular path at any instant is given by along the tangent drawn at that point. ಇಲ್ಲಿ ನೋಡಿ, ಈ ವಸ್ತುವಿನ ವೇಗ ಇಲ್ಲಿ ಈ ದಿಕ್ಕಿನಲ್ಲಿರುತ್ತದೆ, tangent. Velocity at this point is along the tangent drawn at that point. Velocity at this point is along the, say, body moving along an anti-clockwise direction. I will assume here body moving along anti-clockwise. See, velocity at this point is along the tangent drawn at this point. Say, velocity at this point is along the tangent. Say, along the tangent. Say, along the tangent. Say, along the tangent. We study more about it, student. Next chapter, motion in the plane, because it's a good example. Circular motion of a particle. That is, motion of a particle along a circular path is a good example for two-dimensional motions. Motion in a plane. Motion in a plane. See, directions of the velocity continuously changes. the magnitude of the velocity remains constant, magnitude of the velocity means speed of the particles. Got it? Therefore, if the speed is constant, velocity may not be constant. It's a good example to understand this one. See, here when a particle moving along a circular path with speed 20 meters per second, at any position in its path, say A, B, C, D are different positions. At any position in its path, the speed is 20 meters per second. Means magnitude of the velocity is 20 meters per second. But direction continuously changes. We know when direction of the velocity changes, the velocity of the body is said to be non-uniform. Got the idea? See, if the speed is constant, velocity may not be constant. What about here? How can you write under the velocity column? If velocity is constant, speed is always constant. Means velocity constant means both magnitude and directions of the motion of the particle remains constant. Isn't it? Both magnitude and directions of the velocity of the particle remains constant. If magnitude is constant, it is enough to say speed is constant. Therefore, if velocity is constant, comma, then speed is also constant. Then speed is also constant. Speed is also constant. Got it? Speed is also constant. Or if velocity is constant, speed is always constant. Got it? Important difference. So fifth one, say fifth one. What about speed? When discussing the instantaneous speed, I am explaining rapidity or slowness of a moving body varies from instant, maybe varies from instant to instant. The speed of the moving body gives an idea about how quickly body moves or how slowly body moves. Therefore, speed gives an idea about rapidity of motion of the body. Speed gives an idea about, got it? Speed gives an idea about rapidity of motion of the body. Rapidity means how quickly body moves and how slowly. See, rapidity of motion of a body. Rapidity of motion of a body. Rapidity of motion of a body. Speed. What about velocity? See, speed gives an idea about how quickly body moves. But velocity, how quickly as well as in what direction body moves. ಎಷ್ಟು ವೇಗದಲ್ಲಿ ಮತ್ತು ಯಾವ ದಿಕ್ಕಿನಲ್ಲಿ ವಸ್ತು ಹೋಗ್ತಾ ಇದೆ. Like that. See, velocity gives an idea about velocity gives an idea about rapidity as well as position of a body in motions. Rapidity as well as position of a body in motions. Rapidity as well as positions of a body. Positions of a body in motion. Positions of a body in motion. Here is our student. Difference between speed and velocity. Important question. I discussed 5 differences. May I ask either for 2 marks or 3 marks. See, what are the important differences between speed and velocity? First one, the distance traveled per unit time is called speed. The distance traveled per unit time is called speed. The displacement per unit time is called velocity. The displacement per unit time is called velocity. It is a scalar physical quantity. It is a scalar physical. It is only magnitude but no directions. It is a vector physical quantity. It is a vector physical quantity. Speed of the particle is always positive because this is scalar quantity. Scalar never be negative. Velocity of the particle may be negative, 0 and positive. May be negative, or it may be 0, or it may be positive. If the speed is constant, velocity may not be constant. I explained this one by a good example. When a particle is moving along a circular path with constant speed, even if the speed remains constant, its velocity continuously changes because directions of the velocity at any point in its path is given by the directions of the tangent drawn at that point. See, I was assumed here particle moving along a circular path with constant speed 20 meters per second in anti-clockwise directions. Then these are all the what? Directions of the velocity. See, directions of the velocity continuously changes. Therefore, speed is not possible to say constant. Hence, if the speed is constant, velocity may not be constant. Got it? If velocity is constant, then speed is also constant. Means, if velocity constant means both magnitude and direction remains constant. If magnitude is constant, it is enough for to say speed constant. Next, speed gives an idea about rapidity of motion. What is rapidity? Measure of quickness or slowness of a moving body. Got it? Speed gives an idea about rapidity of motion of a body, but velocity gives an idea about rapidity as well as position of a body in motions. Means how quickly and in along what direction body moves. That gives by velocity. Therefore, velocity gives an idea about rapidity as well as position of a moving body. Read out, students. It is about what? Difference between the speed and velocity. Difference between not the speed and velocity. Okay. Now I am going to discuss the next topic of the chapter. Very important topic, accelerations. So far studied what? Position, distance, displacement, speed, velocity, difference between speed and velocity, difference between distance and displacement. Now I am going to discuss the one more physical quantity associated with a moving body is known as accelerations. Is known as what? The accelerations. Just before discussing the difference between speed and velocity, I am discussed about what? Variable velocity. Isn't it? Difference between speed and velocity ಹೇಳುವ ಮೊದಲು ನಾನು ವೇರಿಯಬಲ್ ವೆಲಾಸಿಟಿ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಹೇಳಿದ್ದೇನೆ. That is, a body is said to have variable velocity if it changes its magnitude, or if it changes its directions of the velocity, or if it changes both magnitude and directions of the velocity. Isn't it? Or velocity of the body is said to be non-uniform if it undergoes unequal distance displacements in equal intervals of time, or equal displacements in unequal intervals of time, or unequal displacements in unequal intervals of time. Then velocity of the body is said to be non-uniform, or velocity of the body is said to be what? Variable. When the velocity of the body is variable, ಒಂದು ವಸ್ತು ತನ್ನ ವೇಗವನ್ನು ಬದಲಾಯಿಸಿದರೆ, see, when velocity of the bodies changes, then we can describe its motion in terms of acceleration. We can describe its motion in terms of accelerations. We can describe its motion in terms of accelerations. The next topic is what? Accelerations. ACCELERATION. Acceleration. In Kannada, ವೇಗೋತ್ಕರ್ಷ. In Kannada, ವೇಗೋತ್ಕರ್ಷ. Study ಮಾಡಿದ್ರು. Velocity is known as in Kannada, vega. Acceleration is known as ವೇಗೋತ್ಕರ್ಷ. We know accelerators. Common word. Accelerators. To increase the velocity or to decrease the velocity of a motor bike. Okay, what is accelerations? We know when the velocity of the body changes, when the velocity of the body is non-uniform, then we describe the motion of the body in terms of its acceleration. Therefore, what is acceleration? In order to define acceleration or in order to discuss acceleration, the velocity of the body should be what changes. Therefore, whenever velocity of the body changes, then rate of change of velocity of your body is called accelerations. Got it? That is the rate of change of velocity of your body. The rate of change of. The rate of change of. The rate of change of. Or rate of changing. The rate of change of velocity of a body. Or the rate of change of velocity of a body or of a particle is called an acceleration. Is called an accelerations. Is called an accelerations. Okay? ವೇಗೋತ್ಕರ್ಷ ಎಂದರೇನು? ಒಂದು ವಸ್ತುವಿನ ವೇಗದಲ್ಲಿ ಬದಲಾವಣೆ ಆದರೆ, ಒಂದು ವಸ್ತುವಿನ ವೇಗದಲ್ಲಿ ಬದಲಾವಣೆ ಆದರೆ ಆ ವೇಗದಲ್ಲಾದ ಬದಲಾವಣೆಯ ದರವೇ ವೇಗೋತ್ಕರ್ಷ. ವೇಗದಲ್ಲಾದ ಬದಲಾವಣೆಯ ದರವೇ ವೇಗೋತ್ಕರ್ಷ. Got it? See, the rate of change of velocity of a moving body or the rate of change of velocity of a body is called an acceleration. That is acceleration of a body. That is accelerations is given by, say, accelerations is equal to what? Change in velocity. See, change in velocity. Change in velocity divided by time difference. Change in velocity divided by what? Time difference. See, acceleration is given by change in velocity by time difference. ವೇಗದಲ್ಲಾದ ಬದಲಾವಣೆ ಭಾಗಿಸಿ ತೆಗೆದುಕೊಂಡ ಕಾಲ. ಅಂದ್ರೆ ಅಷ್ಟು ಬದಲಾವಣೆ ಮಾಡಲು ತೆಗೆದುಕೊಂಡ ಕಾಲ. That's called acceleration. Change in velocity divided by what? Time. That's called what? Accelerations. So unit SI system, unit in SI system. So what the unit of the acceleration? SI unit. So SI unit is given by change in velocity. We already studied velocity, meter per second. Change in velocity is also meter per second. For example, see, velocity of the body changes from 40 meter per second to 60 meter per second. Then what is the change in velocity? What is change in velocity? 60 minus 40, 20 meter per second. There is no change in unit. Therefore, unit is what? Meter per second divided by time taken, second. Meter per second by second. What is meter per second by second? Meter per second square. Got it? Therefore, unit is given by what? Meter per second square. Meter per second square. Therefore, SI unit of the velocity, sorry, acceleration is given by meter per second square. This is the SI ಮೂಲಮಾನ ಪದ್ಧತಿಯಲ್ಲಿ ವೇಗೋತ್ಕರ್ಷದ ಮಾನ. ವೇಗೋತ್ಕರ್ಷದ ಮಾನ. What about dimension? Simple. If you know the unit, we can write dimension very easy, isn't it? Let's call dimensional formula. So meter is the unit of physical quantity known as length. The dimension of the length is what? L. Dimension of the length is what? Say capital letter L, represented by L. Meter to the power of 1, so L to the power of 1. Second to the power of minus 2. Second is the unit used to represent time. So dimension of the time is given by T, capital letter T. Therefore, T to the power of minus 2. Therefore, LT inverse 2. Or we can say in mechanics, mass, length and time are the three important fundamental physical quantities. Therefore, m to the power of 0, L t to the power of minus 2. Or simply we can write LT inverse 2. LT inverse is what? Dimension students. Need out? What is acceleration? What do you mean with the star? ವೇಗದಲ್ಲಾದ ಬದಲಾವಣೆ ಭಾಗಿಸು ತೆಗೆದುಕೊಂಡ ಕಾಲ. ಅಂದ್ರೆ ವೇಗದಲ್ಲಾದ ಬದಲಾವಣೆಯ ದರವೇ ಆ ವಸ್ತುವಿನ ವೇಗೋತ್ಕರ್ಷ. That is, acceleration of a moving body can be defined as the rate of change of velocity of a body is called accelerations. See, acceleration equal to change in velocity we can take up. So acceleration equal to change in velocity. Time taken is 1 minute. In our textbook given, acceleration can also be defined as. See, acceleration. I am going to give you one more definition. Acceleration can also be defined as. Acceleration can also be defined as. See, changing velocity by time taken. When time taken is 1 minute, 1 second, or say unit. See, acceleration is equal to change velocity. Time taken is 1 minute. Therefore, acceleration can also be defined as changing velocity per unit time. Changing velocity per unit time. Changing velocity per unit time. Acceleration can also be defined as changing velocity per unit time. This is called acceleration. Any doubt? See, so far studied lot difference between speed and velocity, and also about accelerations. That's whenever velocity of the body is non-uniform, then that body is said to move with accelerations. So acceleration of a moving body can be defined as the rate of change of velocity of a body with respect to time. We can use with respect to time. Rate of change of velocity of a body with respect to time. We can write with respect to what? Time. With respect to time is called. There is no need. Rate itself indicates that with respect to divided by timing. With respect to divided by timing. Kannada we say that tara. See, with respect to time is called accelerations. Is called accelerations. We know acceleration can also be different because acceleration equal to change velocity by time taken. See, acceleration equal to change velocity when time taken is 1 minute. Therefore, acceleration can also be defined as change in velocity per unit time. So, SI unit is given by meter per second. By second, meter per second square. Dimension is given by LT inverse 2. It is the what? Dimensions. Students, so far studied lot about velocity, instantaneous velocity, difference between speed and velocity. Again, we studied about accelerations. Again, I explained about SI unit and dimension of the accelerations in these sessions. I hope that all of you understood clearly. Still, if you have any doubt about today's topic, please feel to ask with your respective physics subjects. Okay, thank you very much.